Okay, this is Mr. Palomine, your secondary instructional math coordinator for grades 7 through 12. We're going to be going over solving two-step equations and inequalities, the standard 711A. I'm utilizing things like strip diagrams, pictorial models of algebra tiles, pictorial abstract, but I will be using the little poly pad, you see me kind of hovering over it, to kind of get you going through the concrete pictorial abstract process of learning mathematics. This is these videos will be in this site right here. It says untitled right now, but it'll say this. 711A solving two-step equations and inequalities will be the title of the Google slide. The slide is intended for teachers teaching two-step equations. All right, so here we go. Modeling with strip diagrams, first thing that you can show your students to do as a beginner to your algebra tiles. You go with tiles first, but I don't mind doing the strip diagrams first. Strip diagrams is something they should have been seen since kinder. And so all we got here is we got 3x plus 4 equals to 16. Notice that the area of this rectangle is the same as the area of this little rectangle. So it's really strip diagrams are a gift to keep on giving. You can utilize them all the way through here and even further. So I got 3x plus 4 equals 16. This really works really nice when you have, for example, everything's positive here. So, you know, I can say this whole thing is 16 from here to here. You can draw a little line here saying from here to here is 16. I know this little part right here is that plus 4, and then I got 3x. I don't know the size of them, but I just know this. I got an x, and an x, and that's one way you can model it, right? So you have the students model this. This is 3x plus 4 equals to 16. Have that conversation then about this little part over here, right? So what is this going to be? And then have that little arrow progression going. We're going this way. And then over here, what you draw here is you draw a 4 and a 4. And your 3x is going on over here. I might not need all 4, but you know, again, we'll figure that out a little bit. If this part is 4 and this part is 4, what's the rest of it over here? You know, subtract the 4, you know, there should be a 12 and so on. And that might be it. That's all I need to know. Now, this part, you can shape that in. You can exit out, say, you know what, I got this part done. It just depends on you as a teacher on what you want to do. I can say, hey, this part's finished already. I don't have to worry about it. I have some students that say, here's the x. It kind of leads into that abstract component of minus 4 on both sides, right? And now you have this talk. So this little part is 3x. How much is each part, right? So I probably only need like three sections, 3 drawings here. I know this is 4, and that part is 4, and that part is taken care of. I'm gonna do that. How much is each x? Well, you know, what is 12 divided by 3? Then I can write it like this. This x, and this x, and then kind of draw your line coming down here. And this 12 cut into, you know, the 3 equal parts would be a 4, a 4, and a 4. And now you're done, right? So I know that x equals to how much? 4. And you can write that anywhere you want here now. We can write in here, x equals to 4. And you're pretty much finished, right? So that's it. You can always check your answer. I guess that could just be the checking your answer part here, right? So let's check our answer. So I got 4. Let's see here. 4, and 4 is at what? Is at 16. Yes, it works out. So there it is. That's utilizing a strip diagram to solve for a variable. When everything's positive, it's a great tool to use. I do see it, I think, at some point in time being modeled in state assessments. I'm just not too sure yet, right? So again, that part was the part that was phased out over here, or you exit out over here. I hope these videos help. It's an awesome tool for you know, using for solving for a variable. And we got the answer here, x equals to 4. Dun, dun, dun. Easy stuff.